In this video, we're going to continue topic 6.9, which is U substitution. And we're going to look at something that looks a little bit more different, a little bit more AP test-esque, especially on maybe a free response question if this popped up, because if you just had a weird graph of F and they didn't give you much other information. So they want me to write an integral that is equivalent to the integral from 6 to 4 of x f of 1/4 x squared plus 5. So basically I need to do a U substitution in and show what would be equivalent to this. So I'm going to start by just looking for my U. So it looks like that my U is equal to 1/4 x squared plus 5, which would make du equal to 2/4 x, which is or dx, which is the same as 1/2 x dx, which I don't have the 1/2. I do have the x dx part. So in order to get the 1/2, let me rewrite this a bit. Make it a little bit bigger. I'll purposely leave some space. Okay, so we know that we're going to use this as the u. We have the x dx, but I need a 1/2, which means if I'm going to put a 1/2 in here, I have to put a 2 in the front. So that's what we're going to add in. All right, let's actually try to do the u substitution in. So we've got 2, the integral of 4 to 6. Oh, not 4 to 6. We don't want that because we want the u limits. So we would have the f, and then instead of writing the 1/4 x squared to the 5th, we would write u. And instead of writing 1/2 x dx, we would write du. Now I need to change my bounds. So let's look at this first bound. I'm going to put it into the u equation. So for x equals 4, I've got u equals 1/4 4 squared plus 5. Well, 4 squared is 16. 4 goes into 16 4 times, and 4 plus 5 is 9. So my new lower bound is 9. And then I'm going to go to my upper bound here, which is a 6. So x equals 6. I would get u equals 1/4 times 6 squared plus 5. 6 squared is 36. 4 goes into 36 9 times, and 9 plus 5 is 14. So our new equivalent equation would be 2 times the integral from 9 to 14 of f of u du. So we're going to try something very similar in example 26. So again, it looks like I've got a u hanging out in here. I'm going to use that. So u equals 1/3 x squared. That means that du equals 2/3 x dx. I notice I have the x, I have the dx, I do not have the 2/3. So I'm going to rewrite this with a little bit more space so I can add in what I need to add in. And notice it's equal to 9, so it looks a little bit different and weird this time. But we're going to try to figure out an integral that would involve the function, can be inferred involving the function f of u. So if I need a 2/3 in here, that means I need the reciprocal outside, because then it's like multiplying by 1. So that's what we're going to have to leave it as. So I now have these are my blue, and this is my orange. I'm going to go ahead and rewrite. So I've got 3/2. The integral, I'm going to change my limits in a minute, of f of u for the inside, and then for the blue, everything underlined in blue, I would get du. And then I'm still equal to 9, because that I'm just carrying down. All right, now we need to rewrite our bounds. So I've got -6, I'm going to plug it into u. So u equals 1/3 times -6 squared. Well, -6 squared is 36. And 3 goes into 36 12 times. So it looks like I get a 12 in the denominator. I'm sorry, in the lower bound. And then we're going to put a 0. Oh, I shouldn't have used blue. Sorry, let me use red. Put a 0 in, so I end up with u equal to 0. Sorry, for x equals to 0, u equals 1/3 times 0 squared, which would ultimately just be 0. So if we don't necessarily like the order that that's in, it's perfectly okay to actually leave it that way. So actually, I'm going to leave it that way this time. The only other thing that I could do with this is I could, because I just want it to be f of u equals, I could take this and get it to the other side by multiplying by the reciprocal on both sides. So that would give me the integral from 12 to 0 of f of u du equals 3 into 9 3 times, and 2 times 3 is 6. So that would be our final answer on this one.